The problem statement which we were provided was evaluation of offensive memes. We were provided with a CSV file which had words scraped out from images of memes, and in total there were about 7,000 images. The goal was to create a model that categorizes the memes into one of four categories. Either not offensive, and if offensive, then we have to further classify it based on the degree of offensiveness as slightly offensive, moderately offensive, or highly offensive. This problem falls under the category of sentiment analysis, which is a subdomain of NLP, which stands for Natural Language Processing. Well, in today's world, memes are no mystery to us. Hundreds of thousands of memes are shared on social media platforms such as Facebook, Instagram, Reddit, etc. on a daily basis. While as much of a joy they could be to see, they may have a negative impact depending on the type of audience. Say, for example, some content may not be suitable for a younger aged audience, or the content might be offensive to, say, a certain race, religion, or a particular group of people. This arises the need for a moderation system to audit the memes and categorize them on the basis of their offensiveness. This is what our project aims to accomplish. The dataset provided to us consisted of around 7,000 images of memes, out of which the text had been extracted. Upon examining the data, we found that the dataset was imbalanced, the majority of the dataset being non-offensive and minority being highly offensive. To get around this, we upsampled the data. This was done by simply duplicating the values of all the other minority classes till the dataset was balanced. The approach we used for this classification problem is that first we created a binary classifier that classifies if the text is offensive or not. If it isn't offensive, we leave it as it is. If not, we define another model which classifies the text into the remaining three offensive classes. We start by cleaning the data by removing unnecessary columns from the CSV data. Then we used Python modules like regular expressions to clean our data by removing irrelevant parts like numbers, logos, copyright markings, and stop words. We also converted all the text to lowercase to simplify the data. We then tokenized our data and separated it into training set and testing set. After this, we used two pre-trained word embedding models. The GloVe model by Stanford and the FastText model by Facebook. The first model, that is the binary model, classified the text as offensive and non-offensive, the latter of which was left aside. Now for the second model, we used the Keras library, which contained the convolutional and LSTM layers. For both models, we used Adam Optimizer as it works best for these types of problems, and binary cross entropy for the loss function, and ran epochs until the results were saturated. We created separate models using GloVe and FastText so as to compare the desired results. For the binary classification model, the GloVe model seemed to perform better by a small margin, providing slightly higher validation accuracy and lower validation loss. But for the second model, the FastText model performed far better than the GloVe model, providing a validation accuracy of 99.8% and a validation loss of mere 0.37. The models prepared in our research work provided the best accuracy of 98% from the fast text model and 80% from the GLOVE model, which is efficient enough to be able to filter and classify offensive memes in most of the cases. But with time, technology has been evolving at a tremendous pace, and hence, a simple architectural model like this alone would not be sufficient to detect or evaluate the memes in all circumstances. It may even require a human moderator for further and more accurate results. So, to conclude, clearly the field of deep learning is still ripe for further research, and its applications will be crucial for the development of our civilization.